Hey, you guys. This is going to be our first set of notes in Unit 1. So we're going to call this, I'm sorry, Unit 2. So this is going to be called 2.1. And we're going to be moving on to relations. And relations is just another fancy word for a function. Um, you can, so we're going to kind of dive into it. And I want you guys to kind of not think of this as something um, that is just one idea. Relations can be used for almost everything in math. It just tells us that numbers are related with a certain set of rules. Okay. And so a relation is a set of ordered pairs. And we know what ordered pairs are. We have an X and we have a Y. And we can represent this X and Y with a few different variations. We can use a table that you guys are familiar with. We can use mapping. We can represent relations in a graph, and we can represent them as an equation. Okay, so we have a table, mapping, graph, and it can also be expressed as an equation. And the set of x values is called the domain. If you were in my Algebra 1 class, you'd be pretty familiar with domain. And then, of course, the set of y values is our range. Okay, all right. A relation with distinct points is called a discrete relation. Discrete. And discrete is another way of maybe you have a graph, right? And you have a whole bunch of points all over the place, but they don't really have a rhyme or reason. That would be an example of a discrete graph, okay? But if you have, when we have the other option, where a relation that's connected by lines and curves, those are often called continuous, okay? And that makes sense, right? If we have something that's continuous, it's connecting, it's going on and on forever. So you might see a graph that looks something like this. Right, it's continuing. It's not the points are connecting and making some type of there's a rhyme or reason to the points, right? All right. When we talk about a function, there is some you will have points that make a function and points that don't make a function. So let's show an example of a points in a function. You might have a point that says 0, comma 1, and then -5, comma 2, and then maybe 6, comma 3. Okay, notice how our domain, which is our x values, right, our inputs, the dom everything that is our x value is going to be our domain. Notice how they do not repeat. Okay, that's very important. Once you see a number repeating, it is no longer, once you see an x value repeating, I should say, it's no longer a function. Where, let's say we have something like -2, comma 5, and then we have -2, comma 6, um, and then maybe there's a 3, comma 2. Okay, there's nothing wrong with this last point, but the problem is these 2 points, the first ones, how we have the same input of -2, but somehow the output was different. So that doesn't make sense. That cannot work as a function. The rule should be the same. Anytime you put in one number, you should have the same number coming out. So that is one reason why this isn't a function. And you never want to repeat your x values when we talk about functions, okay? These need to be different inputs each time. Alrighty. So the vertical test line is very simple. Let's say we have a function right here. Okay, and let's say that this line represents a function. And the way you would test to make sure that this graph here is actually a function is you would do a vertical, that doesn't look very vertical, but you would do a vertical line through the graph to test and make sure that you are not hitting this graph more than once. Okay, so one example you might see that's not a function is if you see something graphed like this. Okay, we have a circle, right, that looks like is on our graph. But if I put a vertical line through this circle, we can see that it's actually hitting this graph 2 times. So that is what makes it not a function. Okay, you'll see this in probably college algebra, but there is a way that you can graph a circle, okay, but it does not qualify as a function because they they don't pass the vertical line test. So let's look at the bottom. We have an example here where they want us to find the domain of each relation and then determine if the relation is a function. So all we're going to do is we're going to list the values of our domain and then list the values of our range, and then we're going to determine whether or not it's a function. So let me use a black. So remember, the domain is all of our x values. So here I have -1, 0, 4, and 6. And thankfully, they've already put this in order. If they did not, you definitely want to rearrange them from least to greatest. So I have -1, comma 0. Oh, sorry, we don't need a parenthesis right here. And then we have 4 and 6. And that would be all of our x values, and that would be our domain. And then our range is going to be all of the y values, right? We have -9, -5, 3, and -2. And when we list these, they do need to be from least to greatest. So it doesn't mean that they're going to line up with the corresponding exponents that they go with. Okay, so the smallest number is -9. Then we have -2. Oh, I'm sorry, -5, not -2. -5 comes first, then -2, then we have 3. Okay, so those would be our range or our y values. Now we have to look at this and they're asking, is this a function? Well, all we need to do is look at our domain and make sure that nothing is repeating. And we can see it is not repeating. All of our domain numbers, all of our x values are different. So we can say, yes, this is a function. Okay, let's take a look at number 2. We are going to, let me use a different color. We're going to list all of our y values first. So we have -3 first, then we have 2 5s, and then we have an 8. So let's go ahead and write down 3, 5, and 8. Notice how I did not write 5 twice. That's not necessary. And then for our range, we have 2, 4, -6, and 0. So let's go ahead and write that. -6, 0, 2, and 4. And then is this a function? No, it's not a function, right? We have this repeating 5, which now makes this not a function. All right, let's look at number 5. This one is mapping, and if you're not familiar, all it's telling us is that whatever the number in the x value, the arrow that it's pointing to, that is our output. So -4 was our input, 0 is our output. So let's go ahead and write our domain. Our domain, it tells us we had -4, -2, and 5. Okay, and then let's write our y's. We have 0, 3, 7, and 9. And if we look here at this 5, we can see that the 5 is actually an input for both 7 and 9. So they did repeat that x value, which means that this is not a function. Okay, it's no. All right, let's try another one. Let's look at number 7. Okay, same thing. One way we could what we can do with this is we can actually list all of these points out on the side and it'd be easier to read. So let's do that. So this first point is -1, 2, 3, +1. Then we have -3, -2. Then we have 0, comma 4. And then we have 2, comma -1. And the last one is +1, 2, 3, 4, -1, 2, 3, 4, 5. And so we're going to go ahead and list our domain from least to greatest. So the smallest we have is -3. We have -3 again, so we don't need to write that. 0, 2, then 4. Okay. And then for our range, we're going to write these from least to greatest. I have -5 as our smallest. Then we have -2. Then we have -1, +1, and then 4. Hopefully you guys could fit that all in your paper. All right, so we see that we actually do have a repeating 3 here, and we even if we could actually do the vertical line test on this graph and see that if I put my vertical line through that -3, I'm hitting 2 points. So no, this is not a function. Take a look at number 8. So we need to find the domain and the range and determine if it's a function. So the domain, remember, is listing all of the x values, and the range lists all the y values. So one thing I want you to think about when it comes to domain is you want to think about from left to right. Okay. So from left to right is my graph. Where does my graph start and stop? Okay. So we can see that all the way to the left, this graph is continuing to go on and on and on forever to the left. And then if we look up here, if we look to the right, this graph is continuing to go on and on and on forever to the right. So the domain for this graph is not ending. It doesn't stop. It would be one thing if there was a graph, a point right here, and it went on and only over to the right, but it doesn't. It goes both to the left and to the right. So it's telling us that the x values are not restricted, that we can have as many x values as there is space for us to draw a graph. So what does that mean? Our domain is going to be every single positive number and every single negative number, which means that it is all real numbers. Okay, so if we look at the range, we're looking at how high is something going and how low is something going. When I think about the word range, I often think about singing. When they ask someone, "Oh, what is your vocal range?" They're talking about how high can you get your voice and how low can you get it. Same thing with this graph. They're asking how high up is this graph going, right? How high up and how low is it going to go? Well, we can see that these arrows are telling us that it's going up and up forever and ever in the positive direction, and it's going down on and on forever in the negative direction. So that means that the range or our y values are not restricted, just like the domain values. So they are going to go on and on forever, up, on and on forever, going down, which means that all real numbers again is our range for this graph. Now, is this a function? Well, we can use our vertical line test for that. And any line that we draw that is vertical, which just means up and down, we want to make sure that we are not hitting the graph more than once. And as you can see, we're not. This graph is not going to repeat any of its x values at all. So it is indeed a function. So you would say yes. All right, let's take a look at number 9. These ones can be a little intimidating when you look at them. You just have to understand what you're looking for when you're trying to find the domain and the range. Well, remember, our domain is asking us how far to the left is something and how far to the right, because this is our x values, right? Our domain is always our x values. So how far to the left is this graph? Well, we can see right here that this graph is stopping right here at this -4, right? If we're going to count 1, 2, 3, 4. Yes, it is in fact -4. And the lowest this graph is going, when we look at the x values, right, it's going as far left as -4. And then how far right is it going? Well, we can see that this is going up and in a positive direction, and that arrow tells us that it's not stopping. And then this one right here is going down in the positive direction, which is also telling us it's not stopping. On and on forever in the positive direction. okay, meaning it's going to increase over time um, when we're talking about our x values, okay? So what does that mean? How do we write that? Well, this is where our practice with inequalities comes in hand. We can say that x is going to always be greater than or equal to -4. Okay, x means domain. That's why we use the variable x. And we can see it's always going to be, we can see that it's getting greater, it's going higher, it's going to the right? These numbers are getting larger when we're talking about the domain or the x values. And that is why x is always going to be greater than or equal to 4. Now we're going to get more in depth about that greater than or equal to sign. There are some times where it may only be greater than, okay? But in this case, because our line is solid, we don't have a dotted graph. For example, you might have a graph that looks like this, okay? You see how this is dotted? What that means is that it's not included, okay? So let's say the graph was right here at -1. Well, then we would say that x is greater than -1 because dotted lines mean that the number is not included. So it has to be greater than -1 in that case. Okay, but since we have a solid graph, this is going to tell us that -4 is in fact included. And so x is greater than or equal to -4. Okay, let's look at our y values. Our y values are asking us, or our range is asking us, how high and how low is this graph going? Well, when I look at this graph, I can see that it is increasing on and on forever and ever right here, and it's actually decreasing on and on forever in this direction. So we could say that it is all positive numbers and all negative numbers on the y-axis. So our range is going to be all real numbers. Check and make sure that this is a function or if it's not. Well, you have to be a little careful because if you look at this at first glance, you might try to do your vertical line test somewhere over here or even right here. And you might say, oh, no, it is a function because we're not going over this line more than once, right? This graph. But you have to be careful because you can see, if you can see right here, if we're to go over this graph, we actually do hit the graph more than once. And eventually, this line is going to go on and on forever, and we're actually going to have more points along the way that are going to intersect the graph more than once. So no, this is not a function. Okay, let's take a look at number 10. And I'm taking my time to go through these because if you're not familiar with them, they can seem a little intimidating, but it just takes practice to know what you're looking for. Okay, so they're asking us for number 10, what is the domain of our circle? Okay, well, the domain, remember, is asking for the x values. So if I look at my x values, how far left is the circle going and how far right is it going? Well, if I look here, the furthest to the left it's going is right here at -2, and the furthest to the right it's going is at +5. So then I would say that my domain, this is now an and inequality. You guys remember and inequalities, right? Our domain is going to be -2 greater than or equal to -2. So -2 is less than or equal to x, okay? Meaning x has to be greater than or equal to -2, right? Greater than is always going to be moving towards the right. So x is greater than or equal to -2, or I'm sorry, and this is an and inequality, and x is less than or equal to 5. Now, one thing you could think about is a number line. A number line, we have -2, -1, And then all the way over here, we have positive 5. Okay, dot, 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 dot. And now we have this circle that somehow meets, right? Somehow starts and stops at -2 and at positive 5. Well, we could think about that as putting a point on a number line. If I have a point at -2 and a point at positive 5, and then it's somewhere in between that value, then we know it's an and inequality. Okay, how do we write and inequalities? Well, we just wrote that right here. X has to be less than or equal to 5, and X has to be greater than or equal to -2. Okay, so if that kind of helps you change your perspective on that, sometimes that's all it is in math, is just changing how something is looked at to better understand it. Okay, now let's look at the range. Same thing, we have another number line. It's just a vertical number line. That's what our range is. That's all it is, a vertical number line. They're asking how far down does it go and how far up does it go? What is the value of our y's? Well, we see that this circle goes as far down as -2 and as far up as positive 4. So we can say that y is going to be greater than or equal to -2 or less than or and equal to positive 4. Okay. All right. Is this a function? We're just going to do our vertical line test and we can see that it does in fact hit the circle, right? This image twice. So it is not a function. Remember, our values cannot repeat when we're looking at our x values. Okay, I want to look at number 13 and 14 as well. And we can see here that it's very short equation, right? It's like, wait, where's the rest of the numbers that I need to determine what the domain is? Well, what I want you to do is, if you don't notice it right away, is I want you to graph these. I want you to graph what kind of graph is y equals -7. Well, it's telling us that our line is going to be at -7. So let me go ahead and make that 1, 2, 3, 4, 5, 6. Yep. All right. And then our line is only going to be at -7. And remember, what kind of line is that? It's a line with a zero slope, right? And a line with a zero slope is going on and on and on forever to the left and on forever to the right. So when we talk about our domain, remember, we're seeing how far to the left and how far to the right. Well, anything that goes on and on forever to eat in each direction is going to be all real numbers. Now, when we look at a range, they're asking us how high is something going, or the graph going, and how low is something going. Well, this graph isn't moving anywhere. It's not going up or down. It's staying steadily at -7. So in this case, we have an equation where our range is going to just equal -7. Same thing here. If we look at number 14, they're telling, I'm going to graph it as well, and they're asking us what is the domain. And this is going to be the other type of graph, right? Where we have an equation that equals just one value, where our x is -1. Meaning that our line is only going to be where x equals -1. And when we look from left to right and we determine our range, our domain, we're asking how far to the left and how far to the right does this graph go? And it doesn't. It just stays at -1. So the domain is going to be x equals -1. Same thing with the range. We're looking at how high and how low it is. And we can see it's going on and on forever in the upward position and on forever in the downward position. So the range is going to be all possible positive and negative numbers, which means our range is all real numbers. Now, is this a function? If we were to do our vertical line test on this graph, we could see that we are actually hitting every single point on this graph. So no, it is not a function because the vertical line is hitting more than one point. Same thing here. If we look, they're asking us, is it a function? Well, if we do our vertical line test, we are not actually going to hit this graph more than once. We're only going to be hitting it once at that -7. So yes, this is in fact a function. So if this helps you remember, any graph with a zero slope or just a line in the in the horizontal direction is always a function. And any graph that is vertical up and down is not going to be a function, and it's actually an undefined slope.